This is Excellence in Maths. We're gonna have a lesson today about factorizing, everything about factorizing. So if you struggle with this topic, you will see the lesson today. It will help you a lot. So there is factorizing into single bracket. There is factorizing into double brackets, factorizing difference of two squares, and factorizing into double brackets, but this one is a bit harder. We'll go over each one of them just so you can see the difference in how to factorize each question based on the type of the question. So the first one is factorizing into single bracket. You always need to look for the highest common factor first. Whenever you see the word factorizing, you look for the highest common factor first. So always. So for the first one here, the highest common factor is 4, so take it out. And then open bracket, then you have x minus 4. The highest common factor here between 18 and 9 is 9. Take it out, you have 2x add 1. The highest common factor here is between 10 and 35 is 5. Take it out. But also, if you look here, there is x cubed and x. So you have to take an x as a common factor, but which one? You take the one with the lowest power, which is x in this case. Then 10x cubed divided by 5x is just 2x squared. Minus 35 divided by 5 is minus 7. X divided by x is cancelled. Same thing here, but it's different. It doesn't have x and y. It doesn't matter. Same rule applies. So here you take 5 as a common factor. And also there is a squared and a. Which one you take? You take the one with the lower power. B and b, you take b. B is the same in both of them. And then open bracket. What do you have here? 10 a squared b divided by 5 ab is just 2a. 15 divided by 5 is 3. ab divided by ab is cancelled. What about the highest common factor between 36 and 48 is? You could say 2. No, but this is not the highest common factor. It could be 4. It could be 6. It could be, it's actually 12. Yeah? So go for 12. That's the highest common factor. What about p cubed and p to the power 4? I go for the one with the lower power, which is p cubed. Q to the power 4, q squared. I go for q squared. Then I do what I did here. I do it here. Same thing. So I divide that by that. What do I get? I get 3q squared. This divided by that, I get minus 4 p q squared divided by b by q squared is cancelled. Okay, what goes in all of these? That's 3 terms. It doesn't mean going to be double brackets. But there is a highest common factor always has to be taken out, has to be out from here. So what do you take out from here? It's 12. 12 again. So 12. As you see, QR is here, QR is here, QR is here. So I take QR as a common factor. Then I divide as normal. 132 divided by 12 is 11. So we have P, because QR is cancelled with QR, minus 96 divided by 12, that's minus 8. QR cancelled with QR, so I leave it like that. 108 divided by 12 is plus 9. And then I have PS. And I close the bracket. Okay? After that, 8 goes in all of that. So I take 8 out. S squared and S, I take S out. T squared, T and T, I take T, the one with the lower power. And I have a open bracket here. U is not in all of them, so I can't take Q as a common factor. When I divide that by that, I just have only TU minus 32 divided by 8 is 4. S squared divided by S is just S. And T cancelled, yeah? Then 64 divided by 8 is 8. ST cancel with st. So that's factorizing into single bracket. Okay. Factorizing into double brackets, always look for the highest common factor. If it's not there, you need to use the rule that this is the product and this is the sum. I assume that you know how to expand. So let us go over expanding quickly. So if I have x at 2 times x at 3, when you expand that, what do you get? You get x squared add 5x add 6. If you notice, I got the 6 from 2 times 3. So 2 times 3, so 6 is the product. And 5 is the sum of the 2 and 3. So if you go here, that's a product, and that's the sum. So when I time what numbers, what a pair of numbers I times, I get for 28, but I add, I get 11. So when you think about it, you'll find it's 4 and 7. I put x in each one of them, plus 4, plus 7. Same thing here. Two numbers multiply them, you get 24. When you add, you get 11. So if you write all the pairs, that gives me 24. So it's 1 times 24, 2 times 12, 3 times 8, and 4 times 6. This is the one that gives us 24, and when you add the two numbers, you get 11. So this is the pairs I'm gonna use. Or that's a pair, sorry, I'm gonna use. So it's x at 3 times x at 8. What about that? 51, I've never seen 51 in my times table. What do? I need to divide this number by prime numbers. The prime numbers we have is 2, 3, 5, 7, and so on. Try these ones and see what you get. 51 divided by 2 is going to give me decimal, so I can ignore it. 51 divided by 3, so it's going to give me 3 times 17. 3 times 17 is 51. 3 add 17 is 20. So that's the right pair. So it's going to become x at 3 times x at 17. What about that? If the product has a negative sign, so I'm not looking for a sum of 4. I'm looking for a difference of 4. So if the product has a negative, so I'm looking for a difference. Same thing here, yeah? So I'm looking for two numbers, and at times when I get 21, the difference between them is 4, which is 3 and 7. 3 times 7. You have to be really good with times table to be able to do factorizing, and actually times table is extremely important. So it's x minus x plus 3 and x minus 7. How I decide the signs? The largest always takes the sign of the middle. The largest always take the sign of the middle. What about this one? Two numbers multiplied, we get minus 48. The difference between them is 8. 48 is actually a complex number, so it's 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. Which pair here satisfy that? I'm looking for a difference of 8, so that's this one. So it's going to be x 4 and x 12. We said the largest takes the sign of the middle, so this has to be minus. This automatically has to be plus, because plus 4 times minus 12 give me minus 48. What about that? Same thing. Two numbers, I multiply them, I get 48, and the difference between them is 4, so it's going to becomes 5 and 9. The largest takes the sign of the middle, so this minus this plus. This is very large number. How can I do that? Same thing, I need to use a prime number. So if I divide by 2, it's going to give me decimal. But if I divide by 3, if you divide this by 3, what do you get? You get 51 times 3. Oh, 51 itself, we already found it here. So this is going to be 3 times 17, and drop the 3. So this is prime numbers. If I times them, I get 153. I need a pair from here, but the difference between them is 8, which is obviously it's 9 times 17. Yeah, the difference between them is 8. So I'm going to write here x9 and x17. The largest takes the sum of the middle, and this one automatically is plus. What about this one? We said if there is a highest common factor, take it out. So the highest common factor here is 2. And I have x squared plus 6x plus 9. Okay. Now I do what I did here on this question. So two numbers multiply them, I get 9, and add them, I get 6, which is 3 times 3. What was the 2? The 2, leave it as it is. It becomes x add 3 times x add 3. So here you times them, you get 9. When you add them, you get 6. And the 2 stays as it is. When you times something by itself, that's called squaring. So you can write it like that as well, x add 3 squared. Same thing here when you take a 2 as a common factor. So you have x squared plus 13x plus 36. Two numbers multiply, you get 36. When you add, you get 13. That's 4 and 9. 4 times 9 is 36. 4 and 9 is 13. And you leave it like that. So this factorizing into double bracket. Double brackets. You look here. What about that? That's called factorizing difference of two squares. To do this, you need to be really good with your square numbers. And you need actually to memorize your square numbers up to 20 times 20. Yes, I mean that. 20 times 20. This is actually very simple. It's so easy to do this one, but it's hard to spot it in exam. So when you factorize that, it's actually x minus 10 and x add 10. Done. Look how easy that. 10 times 10 is 100. Yeah, and why we call it difference of two squares? Because this is square, that's a square, and that's a difference between them. What about that? Same thing. So it's x minus 9, x add 9. What happens if I swap the brackets? Nothing. It doesn't affect anything. Right. What about that? 25 is 5 times 5. That's a square number. X minus 16, so minus 4, add 4. What about that? Same thing, but here I start with 25, take away. So I do the same. 5 minus 4x plus 4x. What about that? 400 is a square number, but you need to know what times what time itself is 400. That's 20 times 20. So 1 times 20, d, and 1 add 20d. What about that? We said if there is common factor, take it out first. So that common factor here is 6. You get 100 v squared minus 1. So it's 6. That's 10v minus 1 and 10v add 1. Same thing here. A minus b, a add b. What is that common factor here? 12. So look first, is there a common factor? Yes, 12 is a common factor. Take it out, so that's 12. What do you have here? You have 4x squared minus y squared. Ah, that's a square number, that's a square number, that's a square number, there's a difference. So I apply the rule of factorizing difference of two squares. I keep the 12 as it is. I say 2x minus y and 2x add y. Oh, okay, there is nothing common between 9 and 4. Yes, but if you look closely, you'll see s in all of them. So when you take s out, what do you get? 9 take away 4 is squared, which is s going to be 3. Take away 2s times 3 add 2s. Okay. Okay, so this was factorizing difference of two squares. You need to spot it. It's so easy, but you just need to spot it. That's all to do with square numbers. Now the last one here is factorizing into double brackets. This is a bit harder one. It's harder because there is a common, there is a value before x squared. We call it the coefficient of x squared. So if you look here, there is a value before x squared. This is actually make you decide that the method which I'm going to show you now. And you use it only if the number here is not a common factor. So 2 here doesn't goes in 9, doesn't goes in 7. So what do I do here? I times 2 by 7 to get the product. So that's my product. So the 14. And still the middle number is the sum. So I'm looking for two numbers, I multiply them. We said that's a product. And when I add them, I get 9. So that's 2 times 7. And here 2 add 7 is right. What do? Do I open brackets? No, I don't open brackets. I rewrite the middle bit using 2 and 7. So it's going to be 2x add 7x instead of that. So it becomes 2x squared plus 2x plus 7x plus 7. What do I do after? If you notice, I keep that and keep that. That's fine. I split here in the middle. Factorize this on its own and factorize this on its own. What's the highest common factor goes in here? It's 2x. Now we have x at 1. What is the highest common factor goes in here? 7. Take 7 out. What do you notice? This bracket is the same here. You factorize again. You take it out as a common factor. So you have x at 1 from both of them. So what is left from here? 2x left here plus 7 left here. So you put it in bracket here, 2x at 7, and that's a factorizing for this question. Okay, let's write here with negatives. So we say 2 times minus 24. By the way, the minus always to belong to what comes after. Okay, minus or negative always belong to what comes after. It's part of it. So when you time this, what you get minus 48. So we said that's a product. And the sum is minus 13. Two numbers, multiply them, you get minus 48. When you add them, you get minus 14. Sorry, here we're looking for the difference of two numbers is 13, which is 3 times 16. So these two gives me a difference of 13. We said if the product is negative, so I'm looking for a difference of that. We said that in the beginning of the lesson. But this time that doesn't give me for minus 48. I have to look here to decide which one of them going to be negative. We said the largest takes the sign of the middle, so this has to be minus. So it's going to be 3 plus minus 16. 3 plus minus 16 is minus 13. I do the same thing. I rewrite the middle term using these two. So 2x squared plus 3x minus 16x minus 24. What happens if I swap these? It doesn't matter. The final answer is going to be the same. This doesn't affect your final answer. Split here. So take the highest common factor out. So x. Then you have 2x add 3. I have here minus 16, minus 24. What is the highest common factor here? There is negative in both, so I have to take the negative out. Always. When you see negative here, always take it out. 16 and 24, the highest common factor is 8. What do you have in bracket? You have 2x add 3. If you get the bracket is the same in both of them, that means you are on the right path. You are doing it properly. Now take 2x as a common, 2x add 3 as a common factor, the bracket, the whole bracket. And whatever left, leave it in the second bracket. So x is left over minus 8 is left over, leave it here. Okay. If you try the method on this one, it's going to be very, very hard. 48 times 24 is a very large number. But if you notice, there is highest common factor here. If you take it out, it becomes easy or easier. So if you notice here, 2 goes in all of them, but you can also try 4. 4 goes in all of them, 6 goes in all of them, 12 goes in all of them, and actually 24 goes in all of them. So when you take 24 out, what do you get? You get 2x squared, add 3x, add 1. Oh, that's so easy now, isn't it? And then we do what we did here. In these two examples, we do it here. 2 times 1, which is 2, so that's my product. And the sum is still 3. So 1 times 2 and 1 add 2, isn't it? And then I rewrite, so I'm focusing only on this. What about the 24? Leave it for now. So we have 2x squared, add 2x, add x, add 1. Open bracket, sorry, split. The highest common factor here is 2x, bracket, you have x, add 1. What about this? There is nothing common. You have to take a common factor out. Here, if you don't have any common factor, yeah, take 1 out. So plus 1, bracket, x, add 1. So you have to take a common factor. Even if there is no common factor, take 1 as a common factor. You see the bracket is the same, so 2x, add 1 in one bracket, and the other bracket which is common between them, x, add 1. I actually insisted to write the leftover first and the common bracket after to show you it doesn't matter. And then put your 24 back. Okay, so that's all the types of factorizing. You just need to practice on it. Okay, and we said the most important, whenever you see a highest common factor, take it out and then see which method is the right method for each one of them.